Speculation is wonderful, but what about actually doing the experiment? So for over 60 years, scientists have actually been trying to communicate with extraterrestrial intelligences, mostly in the sense of listening for artificial intelligent signals from far off in space, and occasionally trying to transmit a message. Probably the earliest attempt that most people are familiar with is the message in a bottle that we tossed out into the interstellar ocean, attached to the Pioneer 10 spacecraft. There was a plaque on one of the legs of that spacecraft, designed by a group involving Carl Sagan, Frank Drake, and other scientists. This plaque is supposed to be a minimal representation of ourselves, to represent us to other civilizations that might encounter this object, currently at a distance of 11 billion miles from Earth, far beyond the orbits of Neptune and Pluto. What we see on this plaque is a human pair of figures, naked. One, the man, his arm raised in greeting, the silhouette of the spacecraft, and a strange star-like pattern on the left, which actually represents a map of where we are located in the galaxy in terms of nearby pulsars, whose frequencies are represented in binary code along each limb of the star-like pattern. At the bottom, we see a schematic of the solar system and the rough trajectory of the spacecraft, and there's a hydrogen molecule represented at the top left. The fundamental transition of hydrogen at 1400 megahertz is considered to be one of the best places to look for an artificial signal, the so-called waterhole, a trough of radio noise in the galactic sky. It's easy to look at this and make fun of it, as some people did when it was launched. NASA was criticized for sending pictures of naked people into space, and women's groups legitimately argued, why is the guy greeting everyone, the aliens, and not the woman? Also, the question arises, most people on Earth probably couldn't understand some parts of this symbolism, such as the pulsar map. So how were aliens supposed to understand it? We don't even know, after all, if they have eyes. Despite all the criticism, it was a symbolic gesture to put this out into interstellar space. The Pioneer spacecraft is moving rapidly, but so slowly that it'll be 50 or 100,000 years before it ventures to even the nearest star, and we don't know if that system has an Earth-like planet. This is not a realistic attempt at communication. Somewhat later, a second artifact was sent into space by NASA, the Voyager record. This is a gold anodized disc, akin to a long-playing record, but actually playing at a half the frequency of an old-fashioned LP, that has coded into it information, including images and musical selections. International committees were formed to produce the music and the signals on this, and in fact the beginning has a set of greetings in 100 of the world's languages, including a message from the Secretary General of the United Nations at the time, and Jimmy Carter, the American president of the time. Once again, this attempt at communication can be criticized, not least because of the musical selections, which were frozen in the late 1970s, and so missed rap, punk, and all sorts of musical genres. Most of the musical selections were chosen by, to be blunt, older white men, and they reflect that kind of a taste. Another criticism was that we're sending into space a technology that is currently almost obsolete on the Earth. Now, the scientists involved did push back against this, pointing out that current digital technologies like CDs, bubble memory, USB drives, whatever you like, are not known to be long-term stable. There's already evidence that CDs degrade after a decade. They argue that the analog technology of this record, which comes with instructions on how to play it, is actually very durable. It's been built to last 100,000 years. We can see the anthropocentric trap that lies in the heart of any attempt at communication. We have to make presumptions about aliens, their intelligence, their culture, their modes of communication. Those assumptions are likely to be wrong, but what else can we do if we're going to try and communicate? The logical scientific perspective is probably that it's much easier to detect a signal that's of artificial origin than to say what that signal means. True communication may be incredibly difficult, extremely unlikely. SETI, the search for extraterrestrial intelligence, has been mostly conducted at radio wavelengths. Frank Drake kicked off the subject as a young man when he conducted Project Ozma in 1959, listening to artificial radio signals from two bright stars. He heard nothing, and he was just fitting this program into other radio astronomy programs of the telescope. Subsequently, larger and more ambitious radio listening programs developed, and at the SETI Institute, they operate an array of antennas in the Northern California Dry Valley, where the radio noise is very low. They're looking at thousands of stars simultaneously to hear radio blips and artificial signals from planets around those stars. The sensitivity of the telescopes has improved a lot in 60 years, but still, in terms of the number of possible stars, the number of possible frequencies that you can listen, and the time span, it's a small fraction of the cosmic haystack of possible communication. Radio SETI also suffered a blow in the 1980s when Congress cut it out of NASA's budget, declaring it a waste of taxpayer money. NASA's charter was actually altered for about a decade to prohibit it from doing the search for extraterrestrial intelligence. The scientists who do this are accustomed to the mockery and the laughter, but they're doing it as their life's work. They're convinced that the statistics argue in favor of extraterrestrial civilizations, and they think that you won't find the answer by speculation and philosophizing. They think you actually have to look. As for the fact that the technology is improving rapidly, to them, that just means the search is beginning to get interesting. After all, as Seth Shostak at the SETI Institute says, nobody told Columbus to sit and wait at the shore with his boats, because a few centuries later, we develop aircraft. More recently, a second form of SETI has developed, optical SETI. This requires the technology of extremely powerful pulsed lasers. If there was an intelligent civilization with such a technology near a star, the star of course would blind out the light, the weak reflected light from the planet, 100 million or a billion times fainter. However, we can put so much energy into a short laser pulse that as seen from afar, it can outshine the sun for a brief fraction of a second, perhaps a nanosecond or less. Inverting this logic, we therefore think it's reasonable to look at nearby stars and sample their light characteristics very frequently, a billion times a second, looking for instants where some artificial signal from nearby the star exceeds the light of the sun. Lasers on Earth have now reached the level of almost a petawatt of power, which can be forced into a tiny interval. So this is not a silly hypothetical experiment. Radio SETI now works in similar ways, also looking for pulsed signals. Wary of the history of radio astronomy, where pulsars were not anticipated and thought to be extraterrestrial intelligent signals, radio astronomers are extremely conservative over the kind of signal they would need to declare success in their search. So far, SETI has been met with 60 years of what's called the Great Silence. Most scientists would be discouraged after such a length of time enduring failure, but not the indomitable people like Frank Drake who do this kind of work. Frank Drake is now retired, but a whole new generation of SETI people involved in technology, radio telescope, and laser development are conducting even more ambitious searches. Microsoft co-founder Paul Allen has weighed in, helping to provide funding for the array of telescopes in Northern California that's currently conducting the most sensitive search yet. The reason SETI researchers are not downcast is that information technology is working in their favor. The capability of searching frequency space is expanding exponentially with information technology and electronics. And that means that the searches currently being conducted can gather more and better data in a year than in the previous half-century of searching. As a thought experiment, it's interesting to note that with the Allen Array, operating in Northern California, we will be able to detect pulsed petawatt lasers, if they exist, or Arecibo-type radio observatories transmitting into space around planets of any of the 100 million nearest stars. That means if continued silence is the result of these searches, we're starting to learn something profound. Perhaps these civilizations simply don't exist, and we are alone. The search for extraterrestrial intelligence is framed by another question that's central to astrobiology. It was posed by the great physicist Enrico Fermi in 1950, long before exoplanets were discovered or we knew how much habitable real estate there really was out there in space. Fermi was a great physicist. His nickname was actually the Pope because most of his colleagues considered him infallible on the subject of physics. Many physics undergrads learn using what are called Fermi problems, which are versions of his very quick order of magnitude estimate way of coming to grips with a problem without doing detailed calculations or using a computer. He was an intuitive physicist. His mind was lightning quick. Fermi's logic applied to the situation of life in the universe went like this. He knew that our civilization and technology is young, and he knew that it's heading in the direction of moving beyond the Earth. A simple extrapolation of current technology early in the space age would argue that in some time, perhaps 100 years or 50 years, but some finite time, we'll attain the capability to travel through space, at least with our robots, if not ourselves. Therefore, he knew that in a fairly short period of time, travel through the galaxy was possible. He also knew that the galaxy is old, There have been Earth-like planets for billions of years, and so the odds that we are the first to attain this capability, should it come soon, are very low. He also knew, in advance of their discovery a few decades later, that it was likely that planets formed as a result of star formation and that our solar system was not unique. So he speculated that many habitable sites for life exist. Putting all these together, he came up with a question that he posed to colleagues: where are they? The Fermi question has many possible answers. One popular book was written giving 50 different answers to this question, but it's a sign of the rich vein of speculation and science that can be generated by such a deceptively simple question.
Some scientists doubt that there are any intelligent beings out there. One of their arguments is called Fermi's question. It's named for the Italian physicist Enrico Fermi, who asked, "Where are they?" His point was that technologically advanced aliens, if they exist, should have visited Earth already. Since they evidently have not, they don't exist. I performed an experiment to test the validity of Fermi's question. At home alone one night, I decided to have lobster for dinner. So I set a place, opened the door to the street, and waited for a lobster to show up and crawl onto my plate. Hours passed. At 11 p.m. I ended the experiment. No lobster had appeared, so I concluded there are no lobster on Earth. Since we know that lobster do exist, clearly there was something wrong with my reasoning. The error was, of course, that I'd failed to take the lobster's preferences into account. Lobster have their own agenda. They don't want to come to my house. But the fact that they don't show up doesn't mean they don't exist. As the SETI scientists like to say, absence of evidence isn't evidence of absence.
Of course, there's a segment of the American public that believes we already know the answer to Fermi's question, that they are here, or they have been here, and perhaps they're frozen somewhere in a government vault, being kept secret from us. Many people know about the X-Files and the science fiction premises that involve alien visitation, to the level where some people think it's unexceptional to believe in such ideas. Astronomers often have to wrestle with the difficulty of explaining why they think that UFOs are not alien visitations. It's particularly interesting because most astronomers are compelled by the statistics of exoplanets and the likelihood that there are habitable planets and perhaps intelligent civilizations out there. The distinction is that they think these civilizations are likely to be far away, thousands or tens of thousands of light years away, and they don't believe that they visited. The reason they don't believe is that the bar is set very high in this subject. As Carl Sagan said, extraordinary claims require extraordinary evidence. And just as astrobiologists will have to clear this high bar when they claim biomarker detection on an exoplanet and the first indication of life beyond Earth, so UFO enthusiasts must clear this high bar when they present evidence of an alien visitation. Through the history of UFO work, of course, most of the evidence involved anecdotal evidence or photographs. We all know, even before Photoshop, how easy it is to alter a photograph, and that's got even easier with digital techniques. And anecdotal evidence is just that. Scientists will only be convinced by physical artifact or physical proof of something that cannot be explained with any other hypothesis. Even within the realm of UFO sightings, it's possible to analyze the data scientifically, approach it skeptically, and decide that something other than visiting aliens is responsible for these sightings. For example, a long time span view of UFO sightings since 1947, which was the famous Roswell incident, shows that there are peaks in the time over decades. UFO sightings are not randomly distributed over time. Many of the highest peaks have been when something important is happening in the space program. The Apollo moon landings, the Mariner first landing on Mars, and so on. None of these objects were visible to the naked eye. What's clear is that the space program was front and center, and on the front page, and in people's minds, and it spurred their imaginations, and they were putting two and two together. When UFO sightings can be explained, which is to say, when somebody reports an exact angle in the sky and a time, such that we can recreate the situation, the single largest explanation for UFOs is observations of the planet Venus. Most people are simply unfamiliar with the night sky or celestial objects, and at low angles of elevation, refraction effects can cause movement that mimics strange behavior. UFO sightings dominate in rich countries. If you look at a worldwide map of UFO sightings, strangely, they stop at the Canadian and Mexican border, which is hard to explain. There are also incredibly few UFO sightings in Brazil, a country with the same population as the United States. Clearly, something cultural is going on here, something that has nothing to do with aliens. UFOs are, of course, the tip of an iceberg of misconceptions and pseudoscience thinking that afflicts Western cultures. We live in the world's most technological society, run by science and technology, and the United States, of course, has incredible prowess in all fields of science, and yet the belief in pseudoscience and superstition is almost at an all-time high. My personal favorite is crop circles, because I was a young boy in England when the first two guys, laborers, went out into a field and with planks pressed down wheat, and then went to the pub and laughed all evening. Copycat crop circles soon began propagating throughout England, then to Canada, the United States, Australia, and now it's an elaborate realm of phenomena where people argue that mathematical theorems are being represented in the pressed crops, and that only aliens can have done this work. We've seen similar arguments about the pyramids, about lines drawn straight across the plains of Mexico, and so on. Ancient astronauts is a trope of pseudoscience, and it really doesn't matter how many times scientists disprove the individual pieces of evidence supposedly presented. People, if they want to believe, will believe. Meanwhile, the real subject of intelligent life in the universe and the possibility of extraterrestrial civilizations remains out there for the taking, but we need scientific observations to decide. Among the possible responses to Fermi's well-posed question, where are they? Let's consider a few, even though we can't decide among them. One possibility, logically, is that they do not exist, at least within our galaxy. That the contingencies of evolution are such that the advancement to intelligence and technology is extraordinarily rare, and we are unique in the galaxy. That cannot be disproven at this point. A related hypothesis is that they're very rare. The civilizations are rare enough that they're far distributed in time and space. What this may mean is that if the average age of a civilization is less than about 3,000 years, and they're randomly distributed through the galaxy, the average civilization cannot have real-time communication or contemporaneous communication with a neighbor, because the civilizations don't live long enough. Space may indeed contain the runes or signals from long-dead civilizations, but actual communication will not be possible. Another possibility that we must take seriously, given the possibility of weird forms of biology, is that they're simply unrecognizable, or that they're inscrutable, in the sense that artificial signals may contain meaningful information that we simply can't recognize or understand. Communication is likely to be very difficult to aliens of unknown function and form. Another possibility, slightly bruising to our egos, is that they exist and don't care. A variant of this is the zoo hypothesis, beloved of science fiction writers, where the intelligent aliens are out there and watching us. A variant of the variant is the berserker hypothesis, which says that as soon as we emerge from our technological adolescence and get a little dangerous, they'll swoop in and eradicate us. These are science fiction ideas, of course, but it is certainly possible that they don't care. Imagine, by analogy, that we go to the surface of an exoplanet and we find microbes, simple bacteria, perhaps unusual bacteria, not like terrestrial bacteria. We would be excited, a biologist certainly would be, and we'd write it down in our notebooks. But it's not exceptional enough to get us really interested. Well, if the aliens are to us as we are to bacteria, advanced by several billion years from us, they might consider us as we consider bacteria. Not really very interesting. A final variation tangents into religion, the idea that super advanced civilizations do exist and that they actually created us. SETI, the search for extraterrestrial intelligence, is proceeding along two fronts. One is the search for artificial radio signals from thousands of nearby stars, and the other is the search for pulsed lasers existing on planets nearby stars, where for a short instant the light from the laser exceeds the light from the star, and we can recognize that technology. By reversing the logical argument, we now have the sensitivity with our radio and optical technologies to detect those technologies on planets around the nearest 100 million stars. If, after a decade or more of searching, we hear and see nothing, it may be a sign that technological civilizations are rare in the Milky Way. Regardless of the outcome, the Fermi question, where are they, is well posed, because there is so much habitable real estate and so much time for intelligence and technology and space travel to develop. There are many ways to answer Fermi's question. Currently, we have no way to decide amongst the fascinating possibilities.